right, let's talk about this warmer. This warmer is the one that the board died on it. And that board is very expensive and discontinued. And so we're going to unintelligentize this. I'm going to install a thermostat and we're going to run the heaters. So we're going to run a quick diagnostic test first. Right, I've done this before, but to prove the concept. So these are all the old thermocouples, so we don't have to worry about those. I've got our power coming into the switch and out of the switch, okay? So that's what'll power my new controller. Now here's all my heating elements, and the schematic shows 3 and 4 are the lower plates, and 1 and 2 are the upper plates. And then there's 2 plates on every circuit. So let's just go with 4. That's the lower bottom circuit, okay? And there are 2 sets of wires. So we can separate those out by groups and say, there's a circuit and there's a circuit. Okay, proof of concept. This heating element, I literally just plugged into an extension cord. And we're pulling 1.5 amps. All right, I'm gonna add circuit by circuit manually first, because I don't wanna go through the wiring process and then find out that we're missing a certain heater, or that there's a heater that's shorted or something stupid. So I'm testing them all. So I've got both lower plates now, and we're heating. I got both lower plates now energized, and we're pulling 3.42 amps. Okay, I know you think this looks like a cluster, but I promise we'll get it cleaned up and sorted, and these 5s are the best way to go. So what we've got is, I'm gonna have to resituate where it sits proper. We've got a new controller in. The switch runs to here, okay? So the black, or the blue and the brown are the switch. My neutral, so one set of leads runs in here to the controller. Over there. The next set of leads, the neutral, runs to the contactor. This leg runs into my heating circuit, and then out of my heating circuit runs my other contactor. So now I don't have the load hooked up or the line. When these are all running, they're going to pull 12.5 amps. The controller's only rated for 10. So we're going to put contactor in there, so the only load on the controller is pulling in the contactor, and then it bears the load. So when we turn this on, she's going to boot up. Oh, you heard the click? Contactor pulled in. Because it's set for 100 degrees. Yep. So it thinks it's heating. Booyah. Now massive wire cleanup. Okay. And then what we've got is all the circuits share 2, right? So we've got, and I could change these to wire nuts if that makes you feel better, but I'm not going to, because I like the individuality of being able to do this. So we've got all the neutral circuits to the uppers, and then all the neutral circuits to the lowers on one, and then we've got all the hots on another pair. So I am gonna leave the thermopile wires in play, just like as I removed things, I didn't destroy them, so that if they ever want to put this control board back in, all the connections are still here. You know, I don't think we are ever going to, but you know, why not? So out of the hot, this is the load, right? So I put an independent load to every set. So we had 4 relays before. 1, 2, 3, 4. So I've still got all 4 wires run in, but we're running 2 out of the neutrals, 2 out of the hots, and they're running straight up. And I'm using heavier gauge wire because these wires are carrying the load. And bonus, the firm wire helps me with my wire management because I get to play right with that. So we're coming out of the switch. I've actually got a thermal disc installed so that if the thing ever runs away and becomes 200 degrees, it's going to terminate the main power to the controller, because you have to have a safety in play. And as the asterisk conversation, right? This is all for educational purposes, right? This machine is not intended, was not intended to run this way. So, that being said, when we power this on, let's see, 3, 2, 1, don't blow up, bang. All right, and we're pulling 12.5 amps, which is why we had to use a contactor, right? If I was running 12 amps through my controller would probably work for a little while, and then it would burn down. So, rolling. Now we put Humpty Dumpty back together. We double check all of our wire connections. And now we have to play the game of temperature settings and temperature offsets. Meaning, we're gonna put sliding pans of chicken in here. So my temperature probe is run in and sitting right here on this plate, in between these two plates. So what we're gonna do is determine at 165 degrees on the actual temperature, what does that put our product in the pan? And then we're just going to fandangle the set temperature to what the actual temperature is, right? So if at 180, our chicken is 150, then I'll actually offset the temperature probe that it reads 150, even though it's actually 180, so that the staff is always able to monitor the physical temperature of the product, not the plate. So while she's heating up, let me get her back. Okay, so don't trust this. So it's set for 145 and it dropped out, and the ambient of the plates has got it still going up. So we're gonna go ahead and put product in here and see. Again, it's kind of like there's no heat load on it. We gotta get the heat dispersed into something in order to get a true gauge.